Okay, so for today, as you can see, we're in lesson 5.3, and we're going to be talking about inverse functions and relations. We've used the word inverse in the past, for example, when we've talked about the inverse of a fraction. The inverse of 3/5, for example, is 5/3. So what happened there is we took the original fraction and we basically flipped it over, or you could think of that we switched places with the numerator and the denominator. Well, that idea of switching two different numbers, or in some cases two different variables, is key to what we're going to be doing in this lesson when we come up with the inverse function. So let me just jump right into an example, but keep in mind this idea of switching two different numbers or variables. It's going to come up quite a bit. All right, so your first two problems are probably going to take you maybe 30 seconds, maybe less. If you're given a relation, which is what you're given here on letters A and B, these two examples, a relation by definition is just a set of ordered pairs. Okay, that's what we have here. So the inverse of a relation is found by very simply taking the ordered pairs, the x, y, and just like I said a minute ago, just switch places with those. So the red is going to represent the inverse of this original blue relation. Just take each ordered pair and switch places with x and y. So there's the inverse of that first, this original relation, and we'll go ahead and do this one as well. Just take each individual ordered pair and switch places with the xy coordinates. Pretty simple stuff. Notice, just like we said earlier when we were talking about the inverse of a fraction, we just switched places with the x and the y. All right? So now we're going to move on to a different type of problem that wants us to find the inverse, there's that word again, of a function. Well, instead of having xy coordinates to literally switch like we did here, we're going to be switching x and y variables. All right? So you just have to remember that when you're looking at function notation, I know this says f of x, but that really means the same thing as y. Okay, so this could have easily could have been written as y equals negative 3x. All right, so there's two different steps that need to be taken when you want to find the inverse function. That first step is, here we are again, switch x and y. Switch places with x and y. Okay, so here's my original function, treating this like y. I'm going to switch places and I get this. So that's your first move. If you're trying to find the inverse function, first step, switch x and y, and then you just have another final step. You're going to solve the equation now for y. So in other words, get y by itself. You could say divide both sides by negative 3. I get it. I'm going to choose to multiply by negative 1/3. I just like that better because I can see the slope better. And so when I multiply by negative 1/3, I get negative 1/3 x on the left. Now when you get to this point, when you're doing this operation of finding the inverse of a function, when you're down to solve for y form, I don't want you to write y. Okay? We're going to use the notation that says the inverse of f, and it looks like this. So in words, this represents the inverse of the original function. So when you get down, you've got y solved for, you're at that last step. Show me, instead of y equals, show me the inverse of the function. And that's what this would say in words. Okay, so we've done the first sentence, basically. That's the answer to find the inverse of the function. All right, so far so good. Now I gave you graph paper so you can do this second sentence. You're going to graph the function, okay, that's talking about what they give you, and then you're going to graph the inverse, what we came up with, and we're going to put both of those on this same graph section. Okay, well let's do this is a line, y equals mx plus b. It just so happens that the b in this case is 0. So we're going to start at 0 on the y-axis. And then I look at the number in front of x as the slope. So from this red dot, my y-intercept, I'm going to count a slope of -3. So I could do negative, or go down 3, right 1, or I could go up 3, left 1. Make as many dots as you need. We're not going to worry about giving rulers out today. If you're doing this at home and you've got a credit card or your student ID card or something like that, if you can draw straight lines, that'd be great. For today, we're just going to do our best, save a little bit of time. And I want you to label each of these. So this is f of x. And I'm going to put the inverse in blue. Okay, so for lines like this, you really have two choices. Pick the one that you think is easier. It's pretty easy to go ahead and graph this. This is y equals -1/3 x. So it has a y-intercept of 0. It's just that it has a slope of -1/3. I'm going to show you a different way, and it relates to what we did right here. Remember, we took the blue relation, which is also, by the way, a function, and we switched the xy coordinates to come up with the inverse. Well, that can be true with graphs as well. I can take this red point right here, which is -2, 1, 2, 3, 4, 5, 6. I'll just write that in there. That's the point -2, 6. And if I want to get a point on the inverse, I just switch those. And I plot 6, -2. Okay, let's see another one of those. This point right here on the function is the point -1, 3. So if I want a point on the inverse, I just take those and switch them, and I do 3, -1. And you'll just do that for all of these points on the red lines. Of course, when you switch 0, 0, you get the same point. Okay, so here's another point. This is 1, -3. So on the inverse, you'll have -3, 1. This point down here is 2, -6. So to get the inverse, I'll do -6, 2. And now I'll connect the blue dots, and that will represent the graph of the inverse. And I'm going to label that as the inverse of f. So that's the completed answer for these problems. You'll do the same thing on 15 through 23. Show me the inverse function, and then show me the graph of the function and its inverse on the same graph section. Okay, let's try another one. So once again, my first move here is to find the inverse function. So I'm going to switch places with x and y. This is really y, okay? Just treat it like y. So I'm going to say x equals y plus 4 over 3. Switch places with x and y, and then step 2 is solve for y. So to solve for y, I got 2 steps, and I got to do them in the correct order. My first move would be to multiply by 3. And then the final move to solve for y would be to subtract 4. Now that I'm down to solve for y, I want you to show me the notation that means the inverse of. So I started with function h. I'm down now to the inverse of h. That little -1 looks like an exponent, means the inverse of. Okay, so now let's graph I'll go ahead and do, since h is in red, I'll do the graph of it in red. You might want to consider changing this so you can see the slope a little bit better and you can see the y-intercept a little bit better. You might consider changing it into that. Means the same thing. y equals mx plus b. So the b, 4/3, is another way of saying 1 1/3, just a little bit above 1. And now from there, you're going to count a slope of positive 1/3, so up 1, right 3. Up 1, right 3. Or if you choose, you could go down 1, left 3. And you would grab some sort of straight edge. For now, we're just going to do our best and connect those dots. So I'm calling this h of x. So once again, you have choices. I'll just do this one a little differently, but if you can identify points on the red and switch the xy coordinates, those are points that'll be on the blue. Or this is easy enough just to do another y equals mx plus b graph. Okay, so this starts at -4, that's the y-intercept. And it has a slope of positive 3, so up 3, right 1, down 3, left 1. Okay, and I think we got enough, so do your best to line those up. And that's not great, but I think you get the idea. And we're going to call this the inverse of h. Something to keep in mind, we dive into this a little deeper in honors, but something should always happen when you have a function graphed with its inverse. There should be a line, and it's always the same. It's the line y equals x. It's really bad. The line y equals x goes diagonally through the origin, just like this. But y equals x is, for these functions and their inverse, they serve as a reflector. So you should always have this scenario where points on the red, for example, like this point right here, should match up. It should have a corresponding point on the other side of this green line. Same distance away. It's kind of what we've talked about in the past, like symmetry, but we call this a reflection line. And that line y equals x is always a reflection line for an original function and its inverse. So you can kind of check yourself and make sure that that's always true. You can kind of see how it works. You have corresponding points that reflect across this line y equals x. All right, now let's do a quadratic. We just did two functions that were both linear. This is going to be a quadratic function, which should be a parabola. First, let's find the inverse function. So once again, switch places with x and y. It's always going to be your first move when you want to find the inverse function. And now, go through the process to solve for y. And we've touched on this early on. This means PEMDAS in reverse. Reverse PEMDAS, okay? Which means the parentheses is going to be handled last. So the first thing, if I'm going in PEMDAS backwards, I will undo the addition first. I undo addition with subtraction. Okay, I will undo exponents next. I undo squaring by square rooting. And if I do the square root of both sides of an equation, I have to include plus minus. So be careful that you do that. So that leads me to what was in the parentheses as the last thing, and that means to undo subtraction with addition. And I'm just going to go ahead and say this. This is what I want you to do. Just so that we don't have any confusion about what you mean, when you come to this point, I want you to take the positive 2, I'm adding 2 to both sides, and I'm going to put it in the very front of this plus minus. So what I'm doing here is what I want you to do. And the reasoning, if you're wondering, well, what's the big deal? It's because I don't want you to do something like this, and I'm not really sure, are you talking about +2 under the radical or not? So to remove all doubt, we're just going to put it in the very front, just like this. Okay, and now that I've got it solved for y, I'm going to use that notation that says the inverse of f. Okay, now let's come up with the graph and the inverse graph. All right, so this is a parabola, and it's in vertex form. The reason why we call this vertex form is I can literally see the vertex. The x-coordinate of the vertex is +2 because this means I'm moving 2 places to the right. The y-coordinate of the vertex is going to be +4 because this means I'm taking the parent and I'm moving 4 places up. So there's my vertex. So let's start there, 2, 4. And then from there, I'm going to just do some inputs and outputs to come up with the other points. So I'm just going to do a little table over here. And I get to pick inputs, but there are better inputs than others. I want to pick numbers for x that are really, really close to this line. Think of this as the center of your parabola, and we're going to build out from the center. So if you have a calculator, if you need it, you might want to grab it. We're going to be inputting 1. That's really, really close to that dotted line, and I don't already have a point there. So you should, on your own, you should make sure that you can figure out what f of 1 is in this case. I'll come down here and do this work. So if we input 1, it means we're doing this. And we want to see what comes out. What comes out is, parentheses first, -1 squared is +1, and 1 + 4 is 5. So if I input 1, I get an output of 5, and that's a point on my graph. And because of symmetry, if I get 1 point, it's really like getting 2, because I can just go on the other side of that dotted line and match it up. I just need one more input. I'm going to input 0. So let's calculate f of 0. This time 0 replaces x. And we want to see what comes out. So parentheses first, -2 squared is +4, and 4 + 4 is 8. So the point 0, 8 is on the graph. And I can match that up, and so is that point. And I got my 5 points that are needed, so we'll go ahead and connect those dots. Make a U shape, and this is going to be labeled as f of x. Okay, so at this point, you do not want to try to graph this because this is the next lesson. You don't really know how to graph this yet. Hopefully you will later this week, tomorrow, Thursday. But for now, you don't have to worry about graphing this. All you have to do, just like we looked at before, is take these ordered pairs. For example, the vertex is the point 2, 4. Switch places with x and y, and you get 4, 2. And that's one of the points on the inverse. And you just do that for all 5 points. So this point right here is the point 3, 5. I'm circling it. That's 3, 5. So if you want a point on the inverse, switch those and you get 5, 3. This point is 1, 5. Switch places with those and you get 5, 1. This point is 4, 8. When you switch those, you get 8, 4. And this is 0, 8 on the red, so the blue will have 8, 0. So here is something that is 100% true every single time. Check yourself. This is a common mistake that people make. When you have an original function, you're given an original function that is a parabola that opens up, like this one. When you're done with the inverse, it should be a parabola to the right, opening to the right, every single time. Now, unfortunately, I have a feeling on Thursday and in next week on the test, I'm going to see some of this because you're thinking, here's the original and here's the inverse. And I get this a lot. Well, that can't be true because I just told you that for an original parabola that opens up, the inverse always has to open to the right, every time. So what do you think if my original function opened down? What would that mean for the inverse? Well, you could kind of intuitively think that that must be a parabola that opens to the left. All right, so just make sure, and notice, again, you can always also check this. Remember y equals x? Y equals x should be a reflection line. I wish I could draw straight lines, but y equals x is a reflection line. We pick up the red, turn it, and set it over on the other side of that blue line. We're done with that one. When you get to these problems, you're going to be given these three problems in particular I'm trying to help you with. You're going to be given functions that are in standard form. And if you're trying to find the inverse of a function, standard form is not a good way to go. It's very difficult to find the inverse of a quadratic that's in standard form. So fortunately, we don't have to because we learned in first semester how to change standard form into vertex form. And that's what we're going to do. So here's a little review on how I change standard form, which is this, into vertex form. You had a couple of tests that involved that. So think back on completing the square. If I'm completing the square, in the parentheses, I would put the square root of x squared. It's just regular x. I would bring down this sign. And then I always look at the number in front of x, and I always divide it by 2. Hopefully it's starting to come back. I know it's been a while. 6 divided by 2 is 3. Now this number that appears in the parentheses, whether you think of it as negative 3 or positive 3, doesn't matter. You're going to square it, and you get 9. So I want you to bring that number that you have in the parentheses after you square it and think of it as being subtracted off of the end of the standard form. It's always subtracted. And now you're going to put those two numbers together on the end, and you're done. 8 minus 9 is negative 1. So this is the vertex form of that blue standard form. And this is where you're going to start working to find the inverse because it's much easier to deal with this form. All right, so here we go. Switch places with x and y. And solve for y. So my first move would be to add 1. Then I have to do the square root of both sides. And then finally I'm going to add 3 to get y by itself. Put it in the very front so I don't mistake anything. And now that I'm solved for y, I'm going to look at my original function was f. So this represents the inverse of f. And that's my answer. And I'm not having you graph these 3. So you'll see that on your assignment. All you have to do is come up with the inverse function. But very important step, make sure you change it to vertex form first. Here's another one. So let's change it first to vertex form. In the parentheses, I'm going to do the square root of x squared. I'm going to bring down the sign, and then I'm going to divide whatever's in front of x by 2. I think some of you are just automatically programmed to go to your calculator and think decimals, but I think you're going to be better off if you just leave it as an improper fraction, because you're going to have to square that number. And what is 7 over 2 squared? Well, you just square each number separately, and you get 49 fourths. And what do I do with 49 fourths? I bring it up here to my original blue standard form, and I subtract it off. Always subtract. Well, I've got a little bit of an issue because I've got a regular whole number and then I'm subtracting a fraction from that, but that's not that big a deal. I have to change 12 into fourths, and that should be 48 fourths. Okay, so I'm thinking of 12 as 48 fourths. I'm subtracting from that 49 fourths. That leaves me with -1 fourth. So that's called vertex form. Now I'm ready to find the inverse. It's just so much easier to find the inverse from vertex form versus standard. Okay, switch places with x and y. And solve for y. So kind of repetitive. I'm going to add 1/4 first. I'm going to do the square root of both sides second. Don't forget plus minus. And then finally, I'm going to subtract 7/2 from both sides. And I'm putting it in front. And now that I've got it y by itself, I'm going to use the notation that says the inverse of f. And there you are. There's the inverse. Okay, the last type of problem you're going to do, this block evens 30 to 38. I'm going to show you how you're going to show your work. Here's the deal on these. Now this is going to tie in what we learned yesterday in 5.2. Now that we know how to do composite functions, we're able to do these types of problems. We're supposed to determine, this is kind of like a proof. We're supposed to determine whether or not two given functions are inverses of each other. And ultimately, we're going to write yes or no as our final answer, but we need to show how we got there. So here's the deal. This should look familiar to you from yesterday. We're going to do two composites. We're going to do an f of g. I'm going to illustrate this on the next slide. We're going to do an f of g composite. We're going to do a g of f composite with the goal of coming up with x in both cases. If that happens, if we get just regular x as a result of these, then the answer will be yes, these are inverses. If one or both of these doesn't come up to be x when we do this, then the answer is going to be no. All right, so here we go. Here are my two functions. It doesn't really matter which way you start. I'm going to start first by doing the f of g composite. So the way I have it written, the g function, which is here, is going to be used as an input into the f. All right, let's see what happens when I input g into f. So 4, and then I'm going to replace this x with x minus 6 over 4, and then don't forget the plus 6. And now simplify. Well, since I'm multiplying diagonally, these two numbers diagonally across from each other can cancel. The 4's would cancel. And I'm left with x minus 6 plus 6. And of course, negative 6 plus 6 is 0. So it does happen that when I do that f of g composite, I get x. All right, that's great, but I still haven't proven anything yet because I still have to get that when I do the g of f composite. All right, so this time the f function is going to be an input into the g. So the f function is 4x plus 6. We just replace that x. And then there's minus 6. And then we're dividing by 4. And then simplify. Well, 6 minus 6 is 0. Leaves me with 4x divided by 4. I can cancel factors. So sure enough, I got x when I did each of these composites. So my final answer, I've proven that these two functions are inverses. So if you come in on Thursday and your answers are just yes, no, whatever, without this proof, I can't give you credit. That's going to be true also on the quiz and test. So make sure you follow what just happened there. The reason why we're trying to get x goes back to the graph. And I'm going to come back to one more problem. Remember this magic line that always serves as a reflection? Well, that just happens to be the line y equals x. So that's really the why behind we're trying to come up with x when we do those two composites. Okay, let's look at another one. Are these two functions inverses of each other? Well, let's see. Let's start with the f of g composite. G is going to be an input into the f. So in place of x, I'm going to put this g function. And then I'm going to go through the process of simplifying, but let's use a little common sense here. If you notice, it really doesn't matter. I mean, I could go through some work here and simplify all of this, but ultimately, even after I do that, I'm going to be multiplying by 2. So you can probably tell that if I'm going to be multiplying by 2 times whatever comes out of this radical, I'm not going to end up with just regular x. It's going to be 2 times something. And since I did not get regular x, I'm going to have you write down something just so I know that you understand what's happening. Did not get x. Therefore, if you want to say therefore in math, it's like a triangle with these 3 dots. This is going to be no. And at this point, you don't have to do the g of f. Okay? Don't worry about it, because you have to get x in both cases for them to be inverses, so this one's not necessary to do. You're done. Here's your answer. And that's a good explanation for the answer. Okay, so I've given you the assignment. I've given you graph paper. Notice the ones here that you're not having to graph. We're going to check these on Thursday. And this will be on your quiz Thursday, but we'll check the homework first. We'll take questions. And if I can help you between now and then.